go deeper into the architectural sciences, it gave me such a unique perspective on the architectural or urban and technical backgrounds of anything to do with buildings. And one of the things that always struck me when I was in that program is how much of the climate change and energy consumption problem worldwide that architecture plays a role in, which kind of led me on a path to try to understand how and why is that a reality. I then received a Fulbright scholarship in 2019, and went to the University of Texas at Austin, where I studied sustainable design and energy studies. And it really gave me an environmental energy markets and legal perspective towards this particular problem. And then after I finished that, I went to Georgia Tech, where it was a very productive time for me. I kind of worked on 3 degrees concurrently together. So one was my Master of Science of Architecture, which was focused on high performance buildings. And this is really where I went deeper into the building science perspectives. Um, this is where we studied building physics, building chemistry, building biology. And I want to say graduate programs in the United States are not very structured like sometimes we see in the Middle East. So it's really up to you to kind of make your curriculum. But those were things I was interested in. I also concurrently studied at the Samnon School of International Affairs at Georgia Tech, a Master of Science of International Affairs, where I tried to look at the institutional policy and political perspectives of energy making decisions. And additionally, my PhD, which really was an amalgamation of all these perspectives together. I was trying to answer the sustainability question in the built environment in the most cohesive way possible, in a way where we're not just hyper focusing on one section of the problem, however, but looking at it from a much larger and cohesive way. Now, currently, I work for the United States Department of Energy's National Renewable Energy Laboratory in Golden, Colorado, right on the slopes of the Rockies. It's a beautiful campus. And the National Renewable Energy Laboratory is one of 17 national laboratories in the United States, all work under the Department of Energy. If any of you have seen the movie Oppenheimer, you've seen Los Alamos National Laboratory, one of our sister labs in New Mexico. You've also seen initially in the film Oak Ridge National Laboratory is another one of our sister labs in Oak Ridge, Tennessee. So we all work together in these facilities towards different ends, anything related to energy in general, but every lab specializes in things. So the National Renewable Energy Lab, from the name, of course, renewable energy is one of our top priorities, but also it's really the premier energy efficiency lab of the United States where we do this research. There's different facilities. I personally work at the Building Technology and Sciences Center, the BTSC, that building in the middle, the research support facility. And I focus, my particular group is residential building solutions and scaling. We work on that, but I also do international work as well for NREL. So I work as a subject matter expert for the Department of Energy on a net zero world project in Cairo, where we're helping the Egyptian government build a cross-ministerial energy modeling unit for the entirety of the nation. I'm the governance lead expert on that. And, I had visited Cairo a couple of times this year, had the great opportunity to meet up with Dr. Nabil and tour AFC's beautiful campus. Also, as well, I recently was selected as a subject matter expert for buildings in the urban environment for Ukraine. And we started work on the Ukrainian project this month. So it's also exciting. So we do both national work and international work. And the point of my presentation here today is that at the BTSC, we really are pushing the frontiers of architectural research with the software, the tools that we develop, the questions that we ask. And I want to kind of take you through a bit of the portfolio of our work, but not to kind of just showcase it. It's more of to tell you how we think about when we approach these things. And I've interacted with a lot of researchers around the world, specifically in the MENA region, where I'm very proudly from. And it's sometimes the difference is not the capabilities. We're very capable. We're very good at what we do. We're sometimes really technically or much better than some researchers I meet here. But it's sometimes the questions and the paradigms that we ask and how we approach problems is something that we could benefit when we think of things such as the BTSC at NREL and how we approach these problems. So accordingly, I'd like to tell you that at the BTSC, we really ask questions. And not just any questions, really. We ask hard questions. And these hard questions are, differ. We ask questions when we think about buildings and building science and architecture, not just basically on the single building scale and not just only on the neighborhood and city. These things extend to things like the county, the governor, depending on where you are, metro areas, state and national, and really international. It's really a matter of scale. And these different scales really beg and require us to have different tools. So we really have developed a portfolio of tools, which I think some of you have already worked with in one capacity or another. Things like we can categorize them into things like building energy modeling, renewables integration into buildings or the built environment as a whole, and even more importantly and more difficult, building energy code assessment, which I think also I want to focus on a couple of those tools which I think would be more interesting also to people to think of on a larger level on the scales that we look at. So when we started developing and thinking about buildings and how do we do research in buildings, we really started off with really what we call the granddaddy of them all, which is the Energy Plus. And Energy Plus is really the core engine. I think most of you or some of you have worked with this. Energy Plus is really an engine that models energy flows, heating, cooling, ventilation, lighting. It's a validated tool according to ASHRAE standard 140. So we know that the results that it gives out are really good, but it effectively is a matrix solver with a lot of equations. So it's not really, doesn't have a good UI. It's hard when you want to model a building in there. You're really working in Notepad on something we call an IDF file. So it really is not very user friendly in that sense. And Energy Plus is, started off in one of our sister labs, Berkeley Labs, and it is being maintained actually at NREL now. So any update that you see, we're actually working on that. But the idea is it's a great tool, but it really has a problem with UIs. And that's why at NREL, we really wanted to change the perspective from numbers and matrices and words to really, models and graphs, right? We wanted to actually see things that are different. So we developed Open Studio. And for some of you that have worked with this, Open Studio is a free software, and it was originally designed for SketchUp, which was a free software. And the idea was to make something available for people to be able to use in model buildings in a free way. Sadly, SketchUp was sold and is now there's a license required, but it's too late to now reverse everything on Open Studio. However, it's still manageable to a particular degree. But it really moved the idea from being able to just look at a notepad to actually look like, as an architect, as an urban modeler at a building, change the geometry there and actually generate, rather than just also large tables, we could generate graphs or things that are more visually digestible for someone to be able to use. And that's what really Open Studio is. I think a lot of the people that are from the more architectural backgrounds also use the suite Ladybug and Honeybee. And also now there's Dragonfly and different integrations. And all of those actually run on the engines we've developed, which is Energy Plus at the core, and also Urban Opt, which we'll get to in a second, which was also developed at NREL, and was led also by another Lebanese researcher, a very good friend of mine, Rawad Al. So we've been doing a lot of work here and doing exciting things. But when we think of things like Open Studio Energy Plus, we really were modeling a building, putting it up there and testing it, right? And I remember, I also didn't mention, but I was a professor at Georgia Tech. I taught over there. I currently also teach at the University of Colorado at Denver over here. And a lot of students, when you teach them energy modeling initially, or they come to you, they show you a simulation. They show you something. They show you numbers. And that always initially is a good learning experience, because when you simulate anything, when you look at something, the important part is that it has to be comparative. We're comparing something to something. When you give me numbers or you give me a graph, without comparing to something else, it really does not say much unless I have a baseline number in my head. And being able to compare is really the power of these tools. And usually in Open Studio, you would either build different variations on your model, but also as well, you could after that we created something called a parametric analysis tool, which allows us to change some parameters and generate different ones. However, it really always is, when you use something with numbers, you really want to effectively optimize it, right? You want to really get to the best result. You can't test every single variation specifically in buildings. And that's why we kind of moved to something which was, we developed BOPT, which is building energy optimization. And BOPT is something I think people are less familiar with, but it really is the more exciting version of this. BOPT is only at this point for residential building designs in general and retrofits. But what BOPT really does is it really allows you to take a building, a reference building, and then using effectively an optimization algorithm, will optimize for the most efficient building designs it can produce while reducing total annual cost and increasing savings, until it actually reaches a point where adding building efficiency measures doesn't make financial sense anymore, and it starts covering the remaining part of it with solar or PV to be able to get to net zero. So it really can tell you on its own how much you can push through um, building energy simulation, how much you can push savings, and then after that, it will tell you that after this particular point, it's actually worth more to put PV on your roof or invest in a PV system to get to net zero. And that whenever we talk about net zero buildings, and we talk about that a lot, but we really need the tool to be able to do this in the most cost effective way, right? And BOpt is one of those wonderful tools that uses an optimization algorithm with our cost objective function and will allow us to give different variations and then really tell us, well, stop there and cover the rest of the PV. And I think, as I said, it flies under a lot of people's radars, but it definitely is one of those tools that are really interesting. But notice that we were always thinking about that singular building approach, right? And that came to the question: buildings are not alone, right? No building is an island, just like no man is an island, as John Donne says. And really, we went towards urban opt. We need to think of things together, right? And an urban opt was also, if you break down the two words in there, urban, as in, we were looking at a collection of buildings, both residential with commercial and different ones, but also as well the opt part. And I really focus on that. People ignore that, the other part of the names usually. And opt is really what excites me as a researcher here, which is the optimization part, right? There are usually, in theory, a almost infinite number of variations you can do. And when you go into urban, you're actually adding more and more variations to those things. Optimization is key. You need to be able to optimize. And what really urban opt does, it optimizes energy systems for urban districts. And for example, in a lot of our projects in Eastern Europe that we do, they rely a lot on energy systems for districts, right? Their initial designs from the Soviet era was initially district systems, and they still like to keep that as a whole. But also, we use urban opt to analyze the energy impacts of the buildings, also looking at microgrids and renewable integration. With a lot of this talk since the Paris Climate Agreement and the NDCs that countries have put together, we talk a lot about renewables and about a path to zero. Every country has a plan: 2030, 2040, 2035. But to be able to really quantify and look at these things, we really need to start thinking of what would the effect of these things be on a grid level, and not just basically on a single building level when we're answering questions like that, right? And this is where kind of our renewable integration questions start coming up. And so to go to our second part of our categories, we're looking at renewable integration and PV Watts. And I think PV Watts is something most people have used. PV Watts is a wonderful, nifty tool. It's based online, very easy to use. You go in, you look at something like a Google map or an OpenStreetMap, you create a polygon of what your building looks like, and it will quantify for you and tell you how many kilowatt hours can you generate from solar energy in that particular area. We keep updating, creating new models for that, and we've done analyses. So I want to tell you, a lot of people do these analyses almost based on a single building, right? But when I put this particular image on the right, we've used PV Watts degrees to do this on national models too. So one can be creative in general to see, depending on resolution and spatial resolution, when you look at it, that you can really scale a lot of these tools to national questions and not just basically be, well, these are the borders of my plot or my building, and how much will this generate, and boom. I think you can with such simple tools, you're able to really look at things and create national level. Again, it's very resolution oriented, but you could create national level studies if needed, or even on smaller scales, as we kind of talked on before. And as I said, PV Watts, very easy to use. But also there's many other renewables that to be able to reach these hefty goals of the NDCs that we look at. So we have a more advanced model, which is the system advisor model, or SAM, that we call. And SAM really doesn't not just only looks at at solar in a particular geographic area, but really looks at things that like wind, geothermal, a slew of different tools as well with storage, but also looks at the financial and performance-based modeling. And really, I will say SAM is really best used on a project scale. So there's a larger project that requires a multiple systems of renewable energy generation and storage. SAM will do a great job with that. However, with climate change and with urban environments being really under a lot of stress, that the next big question that came out, and since we were really talking about our thought process of developing these, was how do we actually look at resilience, right? We're building these systems, we're building these larger integrations, and this really brings us to re-opt. And again, you notice re-opt, opt as an optimization as always. And the other would be RE, which would effectively be our renewable energy.
Yes, I think that you are muted.
Am I unmuted again?
No, you're fine right now.
I'm
Yes.
fine. All right. Yeah.
Yeah.
So when we were talking about Reopt here, really wanted to also, as I said, not just look at a project and be like, well, this is a nice mix of different systems. We really want to optimize all those together. And this is where Reopt kind of comes in, where we're looking at energy systems, but and looking at the most cost effective. That's our objective function. That's what we always ask ourselves when we're looking at an optimization algorithm. What is the best combination of renewable energy, storage, and conventional generation? And when we say the best or most cost effective, it's not just also about cost, it could be about resilience. So what we do is we simulate, for example, what if there's a flood? What if there's, for example, now in Florida, as people are watching on the news, there's a lot of hurricanes happening right now where, the grid can go down. We actually conducted a survivability analysis in San Francisco, which is one of the more interesting pieces of research we worked on, where we looked at well, if there is a grid failure in San Francisco, for how long, based on the systems, would someone survive in the buildings if there's like a large heat wave, for example. And these things start adding to layers of our analysis when we start tackling questions like that, which is, we've noticed that as heat waves increase specifically in Europe, we see sometimes people, 40, 50 people dying in a heat wave in the summer, right? And that's still, of course, a humanitarian tragedy. And how can this be avoided? When we use tools like Reopt, we're able to simulate such things and be able to understand that and in the particular paradigm, in this scenario, this would really give you a more resilient grid than what you're looking at on your own. And that's where Reopt comes in. But really, what I'm really excited to kind of talk to you about is our next slew of things, which is really our building energy code assessment, or national scale, or larger scale models that we look at. And I want to take a bit more time talking about this, right? So this here is a combination of tools that we created, which are called Comstock and RESTstock. And Comstock and RESTstock are very, they are a very unique effort that we've conducted. So Comstock and RESTstock effectively simulate every building nationally in the United States together. And that is a massive effort. Usually we always almost struggle to do a singular building. And I can, of course, go deeper into the details if there's interest. But the idea is that using supercomputers and using statistical tools such as Latin hypercube sampling to be able to select, we've created very large models that simulate every single building, whether it's residential, which is the res stock part of it, so the residential stock in the United States, and the other would be Comstock, which is your commercial stock in the US. And that allows us to, once we've ran these models and we keep scaling them up, so our latest iteration of res stock, for example, contains 2,200,000 individual buildings, which represent each weighted at 63.8. So that would represent almost every building in the United States. And the idea is that now we have data per geographic. So we can look at an individual city, for example, or an individual county, or an individual governor, or whatever the scaling is. And then we could look at, we've ran 160 upgrades for every single building in the United States. And we look at them and which upgrades did better in a particular area versus another. That allows us to now know that, hey, in this particular area here, it's way better to utilize this versus this doesn't work as well in a different place. Or when we do want to do some cost analysis as well, it could be that this really gave us the best savings, but compared to the next best one, it was such a big difference in cost. It really just makes sense to use the next best one because it was just the better option. And I personally work a lot on RESTstock analysis for a lot of cities. So we get a lot of cities with questions about, hey, we have some funding. How do we best approach fixing a problem that we have here? Or how do we reduce our general carbon emissions? So we also, for each individual building in the US, accordingly, we have quantified carbon emissions. So through another data set we created called Cambium. And we use them in tandem to be able to make these decisions. And this is really what I want to kind of tell you about this is the frontiers when we talk about architectural research. Now that we are starting to ask and questions about the built environment in a more detailed way, we have to start asking them really from a policymaker levels way at a larger level. We really tend to get a bit more focused on the individual buildings or even just a smaller development and things. But if we really want to talk about the impact, I've never seen a paper in anything architectural sustainability of green buildings that does not start with buildings use, for example, 42% of energy worldwide or 73% of electricity. You're talking about a very large scale here, but then the paper kind of boils down to something like I'm going to use passive techniques to drive down an efficiency in somewhere in like old Tripoli or Cairo or Rabat or a place. And while these things are useful on an individual single level, these are not without scaling the solution that you've created to more and more buildings, you won't have the impact that you want on a larger thing, which is why we get to things like Comstock and Restock, which allow us. And really building off Comstock and Restock, we wanted to start making it easier to digest. So Comstock and Restock, and I can show you what really the output is a very big, you know, it's a very big Excel file, right? It has all the information and you use it. But for even for a policymaker, how do you digest these? So to be able to make it easier to digest and create things, we created Scout, and Scout allows us to take data from things like a lot of the energy information administration surveys or things like Restock and Comstock or any kind of data available and use it to be able to help to make a policymaking decision. And this really is just a facilitator that helps bridge the gap because sometimes the numbers are there. And if you kind of were looking at it a bit more intently, it kind of is similar to an Energy Plus to Open Studio approach, right? We started off with a lot of numbers, and now we're getting to something a bit more tangible for the policymaker. And really, one of our newest things, which I want to kind of wrap it up with before we open up to more questions and to talk a bit about this is Ochre. And Ochre is one of our newer tools. And I kind of put it in the building energy code assessment, but it really can work from single building to much larger scale. And the idea is in a lot of the paradigms that we discuss decarbonization or electrification, effectively, we're just electrifying every end use, right? So we're adding EVs, we're adding electric vehicles, we're adding smart meters, we're adding a lot of things. And while Energy Plus is a great tool for simulating things, a lot of its elements, a lot of them are static. They don't update dynamically within the actual simulation. So there are ways to hack these things, but it's very not user friendly. And this is where Ochre came in. We kind of looked at it and said, now with electrification really going up, specifically EVs, I will say EVs are the biggest thing that are going to be added to the grid as you go forward into the future. We anticipate almost 10 gigawatts of added electricity loads every year to be added there, and that's problematic. And also as well, we have a lot of new smart systems, right? Smart thermometers, smart lighting, all these things, which are very dynamic according to a lot of things. So Ochre kind of came in to be able to look at a minute by minute resolution over the 8,760 hours a year, to be able to look at that and be able to simulate things like I have stored electricity. When's the best time to use this from the storage? What's the best time? How is my smart thermometer? How would it really affect me over a year if I set my smart thermometer to be eco at 75 Fahrenheit, or maybe, at a comparative thing, 23 Celsius or something like that. And when you change those, how do you really get there? And look at it holistically. And one of the initial studies we did is for around 470 buildings in Colorado. And we noticed that when you put a lot of these smarter systems, so smart thermometers like the Nest, Google makes those, they're very commercially available. This is not like rocket science, and a lot of different things. You would find almost in certain cases, a 73% reduction in electricity. And really the key part of it is when you're simulating how will this integrate from an urban scale at, if all buildings are using this, how is this going to happen? Is this going to overload the grid at certain points? What would happen if grid goes down? How much would my battery last me? Things like that are much larger questions that can be asked and tailored to when using things like Ochre as well, which, as I said, works from individual building to a much larger one. And equally, it's a standard 140 validated tool, which is very similar to Energy Plus in its results, and it's based on a lot of those models. So accordingly, And just to let you know, these different tools, some are easier, some are more difficult, right? But they're all, in general, anything we're producing, we validate. We tend to say, hey, this is validated. This is not that's producing any numbers that are off wrong. Now, as in anything simulation, there's a black box thing, right? If you're putting garbage in, garbage out, that's what I used to learn. Dr. Hisham Isa used to tell us this, Dr. Nabil, and we were learning. If you put garbage into a software, it's going to give you garbage. But if you put good stuff, it's going to give you good outputs as well. And equally, when we look at it, we almost can see this inverse exponential curve of fidelity versus difficulty of use. But the way we kind of see it is we can look at this as different quadrants, right? So some are lower fidelity, give us quick answers. Some are mid fidelities, also quick, but not as quick, but could give us good answers. And then we have our high fidelity, harder to use, but these allow us to give longer answers. And to make this the way we see it is really one gives us a preliminary analysis. The other is really this detailed analysis of a building or a system as a whole. But our slew of tools can also be used in total as in things like strategic planning. And then accordingly, depending on the question that we're asking, we will then find gaps if we don't have them in the tools and develop them, or rely on existing tools to be able to answer questions, whether it's someone coming up with very quick on the fly, is there potential for this? Versus, hey, no, we can sit down and give you a much better answer. Or, hey, we're trying to build a strategy to decarbonize, for example, Bangladesh in 2035. How do we do so? Then we would require harder and larger tools to use. And this really brings us that we're really starting to ask ourselves a lot of questions globally now. Our push has really become something where we're not looking, I know we're called a national renewable energy lab, but really trying to push more for like international in terms of our impact that we're looking at, right? And seeing those, and really brings us to our, our framework of collaboration, or how we work with others also to achieve those. And it really is that we want to tackle these hard questions, but also at the same time, we want to produce impactful solutions. And with that, on the time, I would like to conclude and say thank you and open it up to questions and for a discussion if needed. Thank you so much.
Thank you so much, dear Yasser, for this really valuable insights about asking the hard question. And actually, this is a brilliant point to be addressed by our students, postgraduate students, because this is the initial starting point.
Yep.
So thank you for sharing all these insights, all the software that you've been involved in, all the questions that you've been involved in trying to answer them in a way. So we really appreciate your being here with us, and this is why actually we're doing our webinars, actually, because we'd like to open these questions type. Since I think that most of our guests here are from the Arab world, we might have like hybrid questions.
Oh, 100%. No.
Yeah. Let me start with a question, which is a typical one I'm always asking. Okay,
Yeah.
if I'm a postgraduate student, I'm starting my career in a way, or research career, what sort of skills do I need in order to enter this career? Like, okay, you're talking about a lot of simulating tools, a lot of issues, and touch wood, you have been in a lot of masters and PhD issues. So how to approach this? This nice story, because really it's important and it's really inspiring. And actually, for me, you're always like a good role model for students to talk about. So please give us the insights about this. And before this, let me just thank, we have here my team, Dr. Randa Khalil, she's with us, and she's going to join us with the questions, Mariam, Magid, and Ahmed. So we are all, we are a nice team within this community. So the floor is yours to just.
Great. It's great to meet you all, and thank you so much, Dr. Nabil, for your kind words. And I think what you asked is a fundamentally important questions. A lot of people also from BAU contact me sometimes wanting to go through and ask me these questions. And to be honest, I will say, I think we have a misconception in general that what you need to succeed in a postgraduate program or do well is that you need to come in with that knowledge in hand. And I think that is the largest fallacy you can really approach when you're approaching this. I think your own drive and curiosity are always important, but to be actually tangible and not just talk theoretical things, I think having a good grasp on the importance of the scientific method as a paradigm for generating researcher appropriate questions. And I'll elaborate on this just so it doesn't sound a bit jargony. But while it might be idealistic, I think it's important. When you approach a graduate program, and specifically I'll focus on the PhD here because that I think is the most fleshed out, although just a Master of Sciences is equally as rigorous as a research degree. When you approach that, the goal should not be that what do I need to do to satisfy the requirements for this particular thing, because I'm either going to get a title or I want to get this to be able to move in my career. It's more is that the question that you're asking initially, how important is it? And when you start from how important this question is and how much does it impact, you really are embodying the very spirit of the scientific method, as Thomas Kuhn and even Isaac Newton have really defined here. And the idea is that you don't need to, when you've identified it, you don't need to solve the entirety of it. And there's not sometimes time, scale, scope, or even the funding to be able to do so. However, you're involving yourself in the right track to be able to say, well, I have identified through applying the scientific method that this is really what's important to answer. And then from there, you could look at it and say, well, to answer this question, I might need a lab of 200 students to do. We're a lab of 4,000, and we're really one of the smaller labs. We have much larger labs. Lawrence Livermore is really much larger. But why do we do so? Why do we then need such larger labs if one could answer everything in their PhD? It's because you can't. But the idea is when for example, in my PhD, I looked at how buildings and building performance affects international politics between countries. I, of course, am not in my building and my own paradigm going to solve the entirety of this, but I took sections of it and started working on it, chipping away at it. And the other important part of it is that you should, by the end of your PhD, be in that very small particular subject, the most knowledgeable person on earth, if you've done your work correctly on this subject, and you become a reference for it. So the idea is to kind of clarify it. You don't, not because you're good at Energy Plus or Open Studio is why you're going to go and go into a program that has sustainability building technology. A good program allows you and gives you the mileage to learn what's needed to answer your question. It gives you the time needed to answer it. It gives you the resource needed to answer it. But, God knows when I started this particular journey, Dr. Nabil, you were very familiar with our curriculum at BAU, so how I can, we studied things. We all did those. When I started my Master of Science Sustainable Design, it wasn't that I took on the side and learned extra things about Energy Plus before going. So no, I was curious about the questions, and I had those, and I went with those, and that was enough to get me into the program, right? And then in there, I spent my time learning and knowing how to answer the question I sought out initially. And I also say within your program, you also change your question. And if you don't, you're probably not doing something really good. And in there, you start, as you learn more, you refine that particular question and you refine your paradigm of answering it, and you could get to it. So curiosity and drive are really the main things, but come in asking questions, not thinking tools. Tools are tools and they mean nothing, right? I can give you a hammer and chisel and a piece of marble, and you could either surpass Michelangelo's David, or you could just have a piece of marble and two tools. It doesn't matter. It's what you do with it. And once you have that, then this will give you the encouragement to tackle these things. And usually, by the way, in our things, we pose the questions first. And as I kind of went through this, and then we're like, well, you know what? I don't think we can answer that yet. Let's apply for funding to develop a tool for it or develop a particular capability within an existing tool. It's really a top-down approach, not really bottom-up, where I'm like, oh, I'm good at this. I get that a lot from a lot of people, specifically in the Middle East, that come to me with these questions. It's like, I'm good at this. I'm like, great. This is a good base and foundation, but what are the questions you're asking? And that's really what I always tend to use as a good gauge of a good researcher versus a good practitioner. And not to say one is better than the other. It's just that if you want to go into research, you should ask the right questions.
Thank you very much. Right now, we're going to open the floor for anyone to ask question. بس خلينا نبقى الموضوع concise، يعني الكويشن بس يبقى ماكسيمم في حدود اللي هيسأل الكويشن في حدود ال 20 30 ثانية بس عشان يبقى السؤال واضح، وبحيث ان احنا نقدر المجموعة كبيرة جدا تبقى تقدر ان هي تكون معانا. So the questions are hybrid. If you'd like to ask in English, that's fine. If you'd
please.
like to تتكلم بالعربي, okay, that's fine. احنا ياسر مالتي لانجوج موجود معانا فما فيش
I'm
مشكلة. في
ready.
فرنش كمان يا ياسر؟
And huh?
في فرنش كمان
Yeah,
بالمرة؟
fee. Actually, also Fusha. I'm really good at it. So if you really
طبعا
want to,
أكيد.
I'm more than willing to.
أكيد. لا
So
ياسر ممتاز يعني. احنا سعداء إن أنت موجود معانا.
thank you
طيب
so
if
much.
you'd like to ask a question, please raise your hand. ما أعرفش دكتور رندا عندك question؟
Okay, yes, I can ask. Thank you so much, Dr. Yasser, for your great presentation. Actually, it was impressive, and your journey was very interesting. So I want to ask a question. What changes in architecture education are necessary to prepare future architects for the challenges of sustainability?
That's a great question. I think based on my experience, and I'll also try to keep the answers concise, Dr. Nabil, to be able to get on more people, but that's a really, really personal and interesting one. So as I mentioned, I taught integrated building systems at Georgia Tech, and I teach the integration seminar at CU Denver. And one of the things I noticed, specifically to use the word architectural here, is that I think this is something that I noticed when I started my Master of Sustainability and Sustainable Design at UT Austin. Sustainability courses for architects are full of fluff. They're full of things that usually are good as an introduction for first 1-2 sessions, but I've noticed that they drag on for an entire course. And this is something I tended to want to change when I approached this paradigm. So I think respect the student's ability to be able to understand a lot of the more interesting concepts. However, there's a language that we use. So to let you know about, a bit from an example from my journey, I started taking my courses at the School of Architecture at UT Austin, great university, one of the top 10 architecture programs in the nation. And I was actually a bit disappointed. I was like, okay, well, this is a lot of talk. When do we get to the actual things? But the program itself had 10 courses required, but you only needed to take 2 at the School of Architecture, and everything else is an elective. You could take them at the School of Architecture if you wanted to. I actually went to the School of Mechanical Engineering and Architectural Engineering and took my courses with the engineers. And it was very rough because, you're taking a grad level course with an engineer where you haven't studied, matrix algebra or linear algebra or solvers, or your homework was very easily, the professor would be like, oh yeah, I run this on MATLAB over the weekend. I'm like, what is MATLAB? So the idea is you have to learn these things. And I came out of it. I put myself to it. I learned these things. I really found what I wanted, right? Which is now there's a way to quantify and answer this in a scientific way rather than saying, I implemented this system here and this will solve my problem. Do you have proof? If specifically when you get to real projects, it's going to cause you a problem. But when I started teaching, I was like, okay, I can't teach this like I teach it to engineers. But the concepts that we learned, you could teach them. And if you are interested in this, I'm more than willing to sit down with you and just share with you how I approached it. Is I took down the harder concepts and I took a bit of the calculation parts out of them, but kept them very much intact, where you need a very good scientific understanding to be able to answer your questions. And not to say this, it worked really great because my update of that course won at Georgia Tech the Instructor of the Year award for the entirety of the school. And the idea was, it's not because I was teaching, it's the method, because I got the students as I told them, hey, a lot of this is outside your comfort zone, but I speak your language because I'm an architect too. And we're not going to, hyper focus on give me the right number here. The idea is give me your right scientific reasoning. And, I employ a Socratic method in teaching, which I learned at the School of Law when I was taking courses at the School of Law at UT. I ask questions, and the knowledge has to be revealed through the answers of the students. So it's very interactive rather than it's a lecture where it's like I'm flipping through these. The question is there, and then as they iterate through the answers, you get there. And I found that that's a much better way of teaching, specifically more harder concepts, than just giving them a 50 slide lecture. Ask the question, let them, and you have to make them comfortable. Students usually don't want to be wrong, but the idea of the Socratic method is a wrong answer helps eliminate it. So it's actually helping us get closer, because usually a student of mine might say, well, this is the reason. I'd be like, no, it's not the reason, because 1, 2, 3. Now they learn how to relate this to this, and this is a bit of that experience. But I can talk volumes on this, but I'm more than willing and happy to sit with you and share with you what I've kind of worked on. And I think it has, in both schools, has garnered a lot of praise for that particular approach.
Sure. Thank you so much. I will contact you. Thank you so much.
Of course.
Any questions? Please kindly raise your hand and state your question if you wish, or if you'd like to write it. Oh, yes, Mariam here with us. Yes, Mariam.
Thank you, Dr. Yasser. So my question is, considering the rise of smart cities, how can we describe the workflow of using such tools to conduct analysis and optimization? I mean, how can we envision a holistic and optimum workflow?
That's a good question also. So just to elaborate on it, when you say the rise of small cities, are you talking, for example, in the context of like Egypt's newer cities that are built when you use small, or is there a particular context you're looking at? If you may elaborate on this.
Yes, the context and the approach itself.
Okay, so
Looking at smart cities, I mean.
I will say with the so as you know, and Dr. Nabil is way more equipped to answer this than me because he's the expert on cities and urban urban environments. But the way I will tackle this is from how we answer these things is, cities are symbiotic. They work together. It's not, you cannot look at an individual building. It's not bottom up. It's really top down. And I think in that particular case, with the rise of small cities, as you kind of put it, I think that with that question, we tried to answer with things like urban opt, and even to a particular degree, depending on scale, things like fresh stock, where what we really wanted to do is we say when you look at a city, every change in one element has an effect on all of them. And while you might think, well, how is this possible, it really is, specifically once we electrify a bit more. If you think of it from more of an architectural perspective, we used to build buildings almost to be isolated, right? You build them almost on their own. They're not really connected to a grid. They're really, I'm talking really back in the day. This is just a functioning structure per se. Of course, there are urban implications of like shade on other places and how they create some form of spatial things. But at least from an energy perspective and how a performative perspective, it was really a bit more singular. Now, the more that we go into the grid, ever since we've electrified and every building is connected to a grid, or every building is connected to a plumbing system, or every building is connected to more things, this larger interconnections are making this a larger problem to deal with, and thus is why we needed the different tools. Here, I would recommend things like Urban Opt. Urban Opt is a great tool because it answers both of your questions, which you said, an urban level, and you also said optimization. And Urban Opt really allows you to look at different building types and simulate them together and how they interact together in a larger system that either is providing, whether it's district heating or cooling, or really there's a microgrid that's occurring in a particular neighborhood that you're looking at. And if that scale on its own is not enough, then Urban Opt is pretty scalable. But I would actually also tie it with Reopt. So if you asked about what is the trajectory for how this goes, I'd say a good analysis would be really a connection of Urban Opt plus Reopt, and both are handling two different things, right? One is really handling the building side of it. The other is handling the grid side of it under different scenarios. And this will help us answer a lot of very, do not underestimate the capabilities of those two tools. They can answer, we've used them to answer questions all over the world: Dominican Republic, Argentina, Chile, India. Hard questions can be answered through tools like this. And I think I saw very briefly in the chat someone asking about open source tools. All these tools are open source. When anything we develop at Anwell is open source. We are a nonprofit organization by nature, so anything we develop is that. UIs, however, sometimes we allow commercial. So have any of you used Design Builder, for example? Design Builder is really our Energy Plus. It's just that a British company built a UI on it and makes you pay for it. But a UI is still very valuable. So that is fine, and we don't really ask for money for licensing that. We think of it as someone is actually doing some of the work to help it commercialize to the public. So if they want to take money for their effort, they can. And all of these are open source. We tend to build UIs for some of them, but just so you know, the DOE or the BTO, the Building Technology Offices, discourages us a bit from competing with the private sector. So it doesn't really encourage us to build UIs, although we have a different philosophy of maybe making it easier and free could have more impact. So we're in a bit of a discussion with them about it. But that as it stands, there are some UIs, and then there are some more some more commercially available ones which can be good and have a lot of development in there. I hope that answers your question. And I'm, Mariam, and I'm, if there's more, I'm willing to actually go into it, but I hope that answers it.
Thank you so much. Yes.
Yeah.
Actually, there's a hand raised with from Dr. Sharif Gobran, as a colleague and dear friend here from AUC. Dr. Sharif.
Thank you, Dr. Nabil. Thank you, Dr. Yasser, for a very interesting presentation. I wanted to, over the course of last week, Dr. Nabil knows that we had with us at AUC Ruaya Raslan from UCL, and one of the main topics of conversation that we come across with a lot of people working in our region, specifically in Egypt, is how to really work in what we consider a data scarce environment. So especially when it comes to energy, unlike in the US, Canada, where I was studying, or in many places in Europe, energy data is relatively accessible in a sense for a lot of these buildings and so on. Here in Cairo, it's well, in Egypt in general, it's much harder to get a hold of accurate energy related data. Do you have any maybe ideas on how to go about that, or how any of the tools that you're developing at NERL are kind of considering these data scarce environments in terms of how?
Dr. Sharif, that is a great question, and that is really one that we actually are in the process of answering now, because we've been getting a lot of requests from different countries, specifically for something like RESTOC. And RESTOC is a great tool, but it's very data intensive, right, to do something like that.
Yeah.
And we're in a lot of discussions of how to approach this. So I will answer this in a couple of different ways. First of all, for example, there's a tool we've developed. It's not completely published yet, but I think I have enough leeway to be able to talk about it, which is, it's a new way, and I think this would be of a lot of interest to you, Dr. Nabil, which uses satellite data and thermal mapping to be able to tell you about urban heat islands in certain cities around the world. And there's some tools that already do so, but the difference is for this one here is that it can give you that on an hourly level rather than an aggregated annual. And this is one of our larger efforts that we've been using, where we're like, okay, we don't have weather stations or places here to be able to have air temperatures or different things that we could utilize. However, for example, we've been trying to tackle it in a way where we have this more of a global approach to do this. But for Dr. Sharif, to answer your question directly, I think this is the largest challenge that we face so far. So a couple of things. First of all, I think we are working currently, or trying to form a collaboration with USAID and Google or Microsoft to be able to build a global RESTOC. This is an extremely big effort, but it's an ambitious one, and that's why we're working with these institutions. The other would be, and this is more of a framework we've been thinking about, which is more of a bottom-up scaling approach. And while not ideal for a lot of reasons, however, it could in some way be something that we could use in more data scarce environments. And what we mean is the following. There are usually archetypes or prototypes of buildings, wherever you are in the world. Developers build pretty similarly. I mean, when I was in Cairo, they took me to a couple of the different compounds like Madinati or Rehab or those things. And what I noticed is, in some way, it's like a lot of it is almost like a copy paste of the same building like a million times, right? That's like one archetype. But then you have older Cairo, which has a bit more of an organic feel to it. However, there's an archetype there, and this is an approach we've been trying to do in Ukraine a bit, which is get these and this is good research. I don't know if it exists in Egypt or not, but have effectively and this is excellent PhD research, by the way, if someone wants to do this, and it's really good, which is actually to build energy plus models for the different archetypes that you've identified in Egypt, or in a particular area in Egypt, it doesn't matter. Those, and calibrate it towards, if you take some energy bills from a particular building. So archetypes are being developed, and see, this is great. I see that in the chat. And having archetypes from there, what we've been thinking about is to apply statistical sampling and distribution methods to be able to scale this up. While this data is not as good as when you have actual consumption surveys, which we have here in the US. You could calibrate this larger model depending on number of buildings that that can be confirmed either from your own existing data, GIS, or satellite imagery. Scale it up and sample correctly from again what you've identified as these are the archetypes. This is kind of their distribution in general. run those models and calibrate it to effectively, if you have, some countries do, some countries don't, more of a percentage of how much the building sector uses in terms of energy and electricity. That is a calibrated model. Now, is this a perfect framework? Not yet. We're still in the process of developing something for that, but it really can give you a better option to do so. The other thing I do want to say is that the United States is the most climatically diverse place on Earth. So 26 out of the 30 Köppen climate classifications that exist in the world exist here, and the remaining 4 are really Arctic ones. So one of the workflows we suggested is using our RESTOC data or Comstock data from buildings that we have in similar climates, because we already have energy models for those, take those and modify them to a particular degree, because we build here in a different way than in other places, and then use those as baseline models to start in places where data is scarce. When this is in a case when there's not even an archetype, for example. So it's not an easy thing to answer, and we're really in the process of doing so. And we're really in a project now to do so for the US territories, which we don't have the exact amount of data like we have in the states themselves. That's kind of the approach we're thinking about now. But we also, as I mentioned, the initial like satellite imagery one, we are also thinking of tools from a different perspective too, not just basically Energy Plus in certain ways. And once those come together in a larger effort, I think that can get us closer to answering that. But at this point, archetyping, scaling up, and sampling correctly, if you have a good statistical analysis background, which as a researcher, I think everyone has to have that, then effectively you're able to start getting closer to answering this.
Yeah, thanks for that.
Yep.
Thank you very much, Dr. Sharif. And actually, if anyone would like to add any questions, please raise your hand or write them into the chat box. Until then, yes, did you find yourself that you need to learn any coding or any other skills beside these issues, or
so I will
necessary?
I am of the school of thought that learning to code is as important as learning to write and read at this day and age. I use coding a lot. I use in my analysis of, for example, a lot of the RESTOC data sets, I use languages such as R or Python to do so. For more computational problems, things like MATLAB. You could also, of course, use NumPy and SciPy to do so in Python. But the idea is learning to code is not is something that will be extremely useful tackling anything that has to do with numbers. Let me put it as simple as that. So the idea is that if you're going into more quantitative sections of urban planning or architecture or anything, learning to code will help you automate. And I find myself using it more and more in a lot of different ways. And sometimes, it might not be completely necessary because Excel is effectively a data management tool, but there's a large scale data set. There's a lot of work that has to be done here. I would sit down, automate the process, and it really helped me in a million ways. So my recommendation is, yes, learn how to code, learn statistics or data science in general. And when I say learn that, do not over encumber yourself. You don't need to know everything about these things. You learn what is needed for a particular task, but notice how that comes back full circle to what is the question being asked. Sit down, ask the question, validate through research, a good literature review that this hasn't been answered before, because I've seen so many people replicate the same question over and over again. And then say, what do I need to answer this? And notice when Dr. Sharif asked the question, what I was trying to talk to him about was really more of a framework of answering that, right? Where, you would need archetypes. You would need, if you have those, if you don't have those, we could downscale from, for example, a RESTOC model and then use that. If not, then we would use a statistical sampling technique. Then we would run those numbers. And this is how you structure your answer, and accordingly that. But 100% coding, I would say, is a necessary tool for anything, because at this day and age, a lot of the software that exists can answer most of the things that are, if the way I see it, if a software, a UI exists to answer it, then you're not really pushing boundaries anymore, because already it's been answered. It's really when you need to take it and create a new computational workflow that doesn't exist yet, I think, is where you're starting to push boundaries and frontiers.
لحين حد إن يرفع إيده، أنا في سؤال هسأله بالنيابة عن الناس كلها. أنا عارف سكرت حلو جدا ياسر، أنت قدمت على فول برايت.
يب.
وقدمت كمان على منحة رودس، صح؟
Yes, I was a finalist for awards. Yes.
Yes, brilliant.
Mm.
Please tell us how, I mean, it's a long process, right? To
Yeah.
apply to all these scholarships. So sometimes the students are just get frustrated at the midpoint. They just drop everything, or they say, okay, why should I do all of these process and so
Yeah.
on. Tell us from your experience and insight how to get being motivated to do this, and is really rewarded or not. I mean, if they're going to be awarded something like Fulbright or all
Yeah.
of these scholarships, yani, from your point of view, from your experience.
I mean, that's a great question, and one, you Yani, we struggle with, and I can answer in both Arabic or English, but depending on what you prefer, Dr. Nabil, what do you think?
لا اللي بتحبه.
Yeah, we'll mix both then. Then the idea is as this. Um, when you apply to a scholarship, it's an extremely competitive thing. Keep that in your mind, and that works both to your advantage and disadvantage. Right, your disadvantage is it's competitive. There's like a couple of spots, and everyone wants to do so, and all the brilliant people are coming out and applying to these things. But it also is to your advantage, is because if you don't get it, right, the reason for not getting it is not that you weren't good enough. Okay, keep this in mind. There are needs. There are programs that have needs. There are programs that there's a particular issue that's happening now. There are a lot of things in these very opaque processes that occur that if you don't get it is not a metric of your own worth in this particular case, just because the need doesn't align. And I try to remind myself of that every time to this day. I mean, I'm a researcher. We apply to grants, we submit papers, we apply to different things, we programs. I get rejections all the time. I get acceptances all the time, right? And I've learned really, man, I think the greatest skill is that I don't take it personally. I know I'm good at what I do. It's just that basically maybe whoever was reading maybe there was not a need for this. Maybe this was not what was there. And as you go through them, you have to remind yourself of that. It's not easy to get those things, and that's why it's valuable. Think of it this way: a scholarship is someone is paying you money to study something. That's what from more of a lexical point of view, that's what a scholarship means. You're being paid to go study something, which is a very high honor, really, right? Like someone respects that you are going to take this knowledge and create something useful out of it. So I will fund you to do so. Getting motivated starts with you really understanding that I am as good as a lot of other people, and at the same time I offer something unique. And I think this was something that you always have to believe in, that because your system that generates ideas is very different than the person sitting right next to you. Better or worse is really up to who's receiving it, right? You can apply. If I went and applied for a scholarship for hydrogen fusion tokamak reactors, I have nothing to offer there, right? Whatever I'm offering, that doesn't mean I'm not good at what I do and something else. So it's really aligning what you're doing, applying. And to be honest, the application process is easier than you think. Being honest about it, saying, but by you applying, it's just an indicator that you believe in yourself, even if you don't get it. It's really overcoming that first obstacle that you're going through. That matters the most, because when you apply to things, when I hear of someone that applies to things, I respect them for it, because I'm like, hey, I think you believe you're good enough for these things. And that on its own is, I think, the biggest first step to do so. So many people are like, how do I come to America? You know what? I tell people, you really don't need a Fulbright scholarship. So many, at least in the US, because I'm more familiar in that system, so many labs have grants that are just willing to, when you apply there. I mean, what I do is I'd send an email, but like, hey, Professor X, I'm really interested in your lab and what you're doing. Do you have any open positions? And if so, is there any funded research? If there's funding, you're not paying a dime in tuition. I did 4 degrees in the United States, and I've not paid $1 for any of them. Not because of anything. It's because also the system is that, I'm good at what I do, and that I think all of us here are good at what we do. But on the other side of it, the system itself, if you're confident enough to go up and ask and be like, hey, I'm interested in this. Can I come? If they say yes, you go through the application process, and if you prove to be the most valuable candidate for their needs, you're good to go. So whether it's scholarships, whether it's really sending an email and saying, hey, I want to learn, I want to join your lab, and is there any kind of funded research, you could do so. And it's much easier than you think. And if anyone has any questions about that, please follow up, and Dr. Nabil would share my contact with you. But the idea is that applying to things, apply. I remember Dr. Nabil literally told me this, right? I mean, do you know how I got into Fulbright? Let me tell you this really nice story. I was on the fourth floor in BAU trying to correct some of my sketches and stuff with someone, and Dr. Nabil was like, "Did you see this poster over there?" And it was the Fulbright people. Amidist was putting that. And I'm like, yeah. And he's like, yeah, well, they're giving a lecture now, or it's not a lecture, it's more of like an info session. And I'm like, yeah, but I really need to get this like sketch done. And Dr. Nabil literally, yeah, Shangalni held me with the hand and dragged me to that room in the info session. He's like, you need to attend this. And I attended it. And, it came out of it. I'm like, okay, this seems interesting. I will apply. And then I remember like when we were thinking about it, Dr. Nabil told me this. He's like, if you apply, you have even a 1% chance. If you don't apply, you don't have any chance. And that I think is a really important, as simple as it sounds. Think of it this way: have the courage to submit your applications. Any rejection I get, I take it. It never is nice, just so you know, but it's not connected to self-worth. Keep that in mind. I go back and I say, let me assess this. How can I improve on what I've already done? What can we do? So once you have that feedback loop in there, you're good to go. You're going to get one or the other. There's so many opportunities, and it's easier than you think. Please take that in mind. It's easier than you think, whether it's a scholarship or whether it's sending an email and being like, hey, I'm interested in joining your lab. Do you have funding? Oh, yes. I want to give you a very anecdotal story. I initially was very interested in Penn State. Penn State University is the birthplace of building science. Excellent university. And I sent an email back in when I was applying for my PhD, something in like November, to one of the professors there. He was, in the lighting design lab. Sent him my resume. I was like, hey, I'm really interested in this. And if there's anything available, let's talk. And he sent me an email. He's like, thank you so much. That's an impressive background, but I don't have any funding now. So I'm like, thank you so much. And the application for the PhD closed in January 15, I remember. And things went, and I had, got into Georgia Tech and all that and accepted my offer. And then in June, literally we're talking 6 months after, I get an email from that professor saying, hey, I got some funding. If you're still interested, apply. This is 6 months after the deadline closed. And I sent him like, Professor, thank you so much for still thinking of me. But hey, I already kind of signed up for, a tech. And he was like, that's a great place, best of luck, best of wishes for you. But that also shows you when funding is there, but these things and deadlines and all that doesn't really matter. This was 6 months after the application had closed. When a professor wants you, when you've impressed them, all those things matter way less. So the idea is put yourself out there. You don't know who was just praying that they get you as an applicant, and they never did. But if you never apply, you'll never meet that person. So do that, and that's just one of my many anecdotal stories that I can give you about these things.
الحكي معك يعني الواحد ما بيشبع منه يعني بجد thank you very much for being with us.
شرف صراحة.
انا لو عليا بنقعد مع بعض ساعتين ثلاثه.
بس احنا بنقعد دايما.
بس بجد انا سعيد جدا بيك وفخور جدا بيك وبجد thank you for يعني accepting being here with us. لو في اي questions من اي حد you can communicate يعني we can communicate you or can find you on LinkedIn.
Please LinkedIn, email, يعني all my contact with Dr. Nabil, ويعني please feel free. يعني it's an open book ونحن بنساعد بعض. I'm always very interested يعني helping anyone بالميدل East. That's why my project's بCairo currently, all those. فعن جد يعني anything you have, always remember it's easier than you think. Let me tell you that.
Thank you very much, and I'm really proud of you, and I'm really happy that you are here with us. Thanks for you, and thanks for everyone being here with us today. And to conclude today's webinar, today we were talking about simulation and energy and environmental issues, sustainability issues, and how to get involved into research and be strong enough to apply for scholarships. And this is really essential. This is and asking the big question or the hard question about your research in general. Thank you ياسر ميرسي كتير.
Thanks so much على الفرصة.
دايما على خير.
I think I shared my email in the chat, and of course if anyone wants to يعني they can follow معك على الموضوع. شكرا كتير.
ميرسي كتير ليك ونشوفك دايما على خير.
يلا see you. Bye.